Welcome to ZoomInData. Hello everyone. Thank you for joining the third video in our comprehensive Azure Logic Apps series. In this session, titled Core Concepts, Workflows, Triggers, and Actions Explained, we will cover the foundational building blocks of Azure Logic Apps, the definition and structure of a workflow as the central executable unit. Triggers, the starting point that initiates execution based on events or schedules. Actions, the subsequent operations that perform tasks, process data, and control flow. How these elements interconnect to form automated, scalable integrations. This understanding of core terminology is essential for designing effective workflows and will serve as the foundation for all subsequent topics in the series. If you find this content valuable, please subscribe to ZoomInData and enable notifications to follow the complete series. What is the most fundamental concept in Azure Logic Apps? The workflow is the primary executable unit that defines an automated task, business process, or integration workload. Every workflow starts with exactly one trigger and can include one or more actions. Workflows are created visually in the Azure Portal Designer or via code in JSON, and they run in either consumption, multi-tenant, or standard, single-tenant environments. Define a workflow in Azure Logic Apps. A workflow is a sequence of operations that automates a process by integrating services, data, and systems. It represents the complete logic from event detection to completion, including data transformation, conditional logic, and error handling. Workflows can be stateful, persisting run history, or stateless, ephemeral for high performance. What is a trigger and why is it mandatory? A trigger is the first operation in any workflow that specifies the condition or event required to start execution. Without a trigger, the workflow cannot run. It determines when the process begins, such as on a schedule, when data arrives, or upon receiving a request. Triggers fire either on polling, periodic checks, or push, real-time event notification, patterns. What are the main types of triggers? Polling triggers periodically check an endpoint or service for new data or events based on a schedule. Push triggers, webhook-based, listen for incoming events in real time, such as HTTP requests or service notifications. Examples include recurrence, schedule, request, HTTP callable, and service-specific triggers like when a file is added. Explain how a trigger initiates a workflow instance. When the trigger condition is met, Azure Logic Apps creates a new instance of the workflow. Trigger outputs, such as new data or event details, are passed as inputs to the subsequent actions. Each firing results in an independent run, enabling parallel processing of multiple events. What is an action in Azure Logic Apps? An action is any operation that follows the trigger and performs a specific task, such as processing data, calling services, or controlling flow. Actions execute sequentially or in parallel after the trigger fires and can reference outputs from previous steps. They include built-in operations for logic control and managed operations for external integrations. What are the common categories of actions? Control flow actions, conditions, switches, loops, for each, until, scopes, and parallel branches. Data operation actions, compose, parse JSON, initialize, set variable, and array manipulations. Service invocation actions, connectors to external systems, HTTP requests, or custom code execution. How do triggers and actions relate within a workflow? The trigger always starts the workflow and provides initial outputs that become available as dynamic content for actions. Actions build upon trigger outputs and can pass results forward, creating a chained data flow. This trigger action structure forms the core pattern for all automated processes in Logic Apps. What is the difference between built-in and managed operations? Built-in operations run natively within the Logic Apps runtime for faster performance and no external connection setup. Managed operations, connectors, are Microsoft-hosted proxies for external services requiring authentication and connection configuration. Built-in include control flow, data ops, and some Azure services. Managed cover 1,400 plus third-party integrations. Explain the role of the visual designer in understanding these concepts. The visual designer displays the workflow as a flowchart, trigger at the top, followed by connected actions. It allows drag and drop addition of triggers and actions, with dynamic content pickers for referencing outputs. Changes are reflected in the underlying JSON definition for advanced editing. How do outputs and dynamic content work between triggers and actions? Triggers and actions produce outputs, JSON objects, that become available as dynamic content tokens. Subsequent steps can reference these tokens to use data like email subject, file content, or status codes. This enables data-driven workflows without manual variable passing. What is the significance of run history in relation to workflows? Each workflow instance, run, is recorded in run history with status, inputs, outputs, and duration. Helps in debugging trigger firings, action executions, and failures. Supports resubmission of failed runs for recovery. Describe polling versus push trigger patterns. Polling triggers check periodically, e.g., every minute, for changes, consuming resources even when idle. Push triggers register a subscription and receive real-time notifications, more efficient for event-driven scenarios. Choice impacts latency, cost, and performance. How can control flow actions enhance workflows? Control flow actions like if conditions, switch branches, and loops add decision-making and repetition. Scopes group actions for collective error handling or parallel execution. These enable complex, resilient business logic. What happens when a trigger receives an array? Triggers that support arrays can use split-on to debatch, creating separate workflow instances per item. Improves parallelism and performance for bulk processing. Available on triggers like request, HTTP, or certain managed connectors. Explain the concept of connections in actions. Managed connector actions require creating a connection, API connection, with authentication credentials. Connections are reusable across workflows and stored securely as Azure resources. Built-in actions typically do not require connections. How do workflows support error handling? Use run after settings to define action execution based on previous success, failure, skipped, or timed out. Scopes and configure run after enable fallback paths or termination on errors. Retries can be configured on individual actions. What is the underlying definition of a workflow? Workflows are defined in Workflow Definition Language, WDL, as JSON schemas. Include triggers, actions, parameters, variables, and output sections. Visual Designer generates and syncs with this JSON automatically. How do core concepts apply in both consumption and standard models? Both models use the same trigger action workflow structure. Standard offers more built-in connectors, local development, and multiple workflows per resource. Core concepts remain consistent across hosting types. Describe a simple workflow example using these concepts. Trigger. Recurrence. Every hour, checks for new emails. Action 1. Get emails, Office 365. Fetches new messages. Action 2. Condition. If email contains keyword. Action 3. Send notification, Teams, alerts team. This demonstrates trigger initiation, data retrieval, logic, and output action. What role do variables play in workflows? Variables store temporary data for use across actions. Initialized via initialize variable action, then set or appended. Useful for counters, flags, or intermediate data transformations. How can actions call custom code? Inline code actions execute JavaScript or other supported languages directly. Azure Functions Connector invokes external custom logic. Extends core capabilities for complex processing. Explain the importance of scopes in complex workflows. Scopes group related actions for organization and collective run after behavior. Enable try-catch patterns using run after on failure. Improve readability in large workflows. How have core concepts evolved with AI integration? Triggers and actions now support AI agent orchestration and model context protocol (MCP) servers. Workflows can include agent actions for intelligent decision-making. Core structure remains trigger action but gains adaptive intelligence. Why mastering these core concepts is crucial for Logic Apps developers. They form the foundation for all workflow design, troubleshooting, and optimization. Understanding triggers ensures proper event handling. Actions enable precise logic. Mastery allows building scalable, reliable integrations efficiently. Thank you for watching this session on the core concepts of workflows, triggers, and actions in Azure Logic Apps. If you found this video helpful, please like, share, and subscribe to ZoomInData. More Azure Logic Apps interview and tutorial videos coming soon. Stay connected and keep learning.